Hello students, welcome to my new video. Welcome to topic number 1, Foundation of Physics. Today we are laying down the core infrastructure for everything you will study in physics this year. Units, uncertainties and vectors. Think of this as your foundational toolkit. Without it, the rest of physics simply cannot be built. Let's start with anatomy of measurement. Look at the value, 27.5 centimeter. A physical measurement, never just a raw number, but it made of two components. One is numerical magnitude and another one is unit. Numerical magnitude gives the answer of how much it is, and the unit gives of what you measure. Now, I want to establish the thumb rule, which is always write unit. Whenever you perform experiment or in physics, you have to write unit. Without it, it has no significance. Let's example 500 meter in 20 seconds means nothing. What do you mean by 500 only? Are you running a meters or centimeters? You have to mention what is 500 centimeter or meter. So you must be write unit. As a physics is a worldwide subject, so to make sure scientists and professors across the globe speak the same language, we use SI base units. We have seven SI units, which is fundamental for AS level. You have to understand kilogram, meter, second, ampere, Kelvin. This is a five base units for the AS level. If you go for A level, you have to add two more units, which is a mole and candela. Now, the kilogram is a SI unit of mass. Whenever you measure the mass of any body or structure, you have to mention in always SI units, which is a kilogram. In length, we have a meter. Now, some length is in centimeter, some are in kilometer, but the SI unit of length is meter. Whenever you solve a problem, convert the given length into SI units. Now, time has a second SI units. Current, which is a physical quantity we deal in electrostatics, has a ampere unit. Now, ampere is a scientist name. Now, the temperature. When you deal in thermodynamics, we use this quantity more time. So, its SI unit is Kelvin. Some students say it's Celsius, but the SI unit of temperature is Kelvin. Now, for A level, we use amount. We use in nuclear physics, we deal with molecules and particles. So, in that, we use molecular weight or mole. Now, at last, the luminous intensity, which has a unity of candela. Now, we have a scales of the universe. In physics, we deal not just only for a human-sized object. We look at the tiny structure like atom, nuclear, electron, proton. and all the way up to the cosmic structure like galaxies, solar planets. Now you have to understand and comfortable with this type of scale. You have to remember this scale for while solving a problem. Now here is a base unit. Okay. Now if you go furthermore, then we have kilogram, mega, then giga and tera. By this scale, we have to add three zeros, 30, 30, and 30. Now, if you go for a small structure like a particle and nucleus, you have to go this way: milli, micro, nano, and picometer. For your knowledge, I have to mention the radius of the particle is about 10 raised to minus 15 meter. So you have to mind this all the scale. By this, you can easily understand the problems and you have to convert in SI units as well as this kind of unit. If in question they give a 1 picometer, so you have to understand it is a 10 raised to minus 12 meter. On the other hand, if they give a giga scale, then you have to know that it means it is 10 raised to 9. By this, you can easily solve a problem. Now, next, in physics, you may see various formulas, but some of the formula must be follow some conditions like homogeneity. Uh, homogeneity is like apples plus apples means apples. So from this, you can easily understand the same quantity. If we add, then if add or subtract equate quantities, if their fundamental base, you can say units, are same. If not, they are not adding each other. Here, I show some equation here. Work is equals to kinetic energy plus potential energy. Work. Work has a unit of force into distance. It is given by this F into D. Now, we know that force has a quantity unit is a kilogram meter per second square. Distance has a SI unit is meter. Now, and we got the work unit is kilogram meter square per second square. Now, the kinetic energy is given by half mv square. 1 by 2 is a constant, so it has a no SI units. Mass. Mass is has a kilogram SI unit. Velocity. Velocity has a meter per second. Is square. Now, kilogram as it is square, meter square per second square. Now, here we have a positive. Add potential energy. So, potential energy is given by mgh. M is the mass, g is the gravitational acceleration, which is around 9.8 meter per second square. H is height. Height is a distance, and its SI unit is meter. Now, kilogram into meter per second square into meter. And we got kilogram meter square per second square. Here you can see work is equals to work is a quantity has a unit kilogram meter square per second square is equals to kinetic energy is energy. So it has also a same unit. You can see here kilogram meter square per second square. And potential energy has the same unit. So I can write Work is equal to kinetic energy plus potential energy, which is a valid equation. I think you get my point. Let's take some example. Now, here I take two equation, which is from kinematics, which is first one A is V is equal to U plus AT. V is a final velocity, U is the initial velocity, T is a time, A is acceleration, S is a distance. Okay. Now remember the SI unit of each physical quantity, as I mentioned earlier slides. Now, uh, let's take A. Now, what is in left hand side? We have V. V means velocity. Velocity means meter per second. Now, RHS, we in RHS we have U plus AT. Now, U, it is the initial velocity, means it is a velocity, meter per second. Plus, we have A and T. What is A? A is acceleration. Acceleration means meter per second. Into, we have time here. So, time means second. Okay. Now, we have meter per second as it is, and we also have meter per second. We cancel numerator and denominator. Now, in RHS, we got meter per second. It's like this one, kinetic energy plus potential energy, same unit. By this, you can say this is a valid equation. Okay. Now, take a look on second equation, which is S plus UT. S is equal to UT plus half AT square. Okay. Now, here one quantity is new, which is S is, means distance. Now, do LHS, LHS means S, S means distance. Remember, recall what is the SI unit of uh, distance, which is meter. Now, in RHS side, we have UT. U means meter per second, and T means time, means second. Half, which is a constant, we eliminate them. Now, uh, A means meter per second square. Now, T means time, means seconds. Now it's cancelled and it's also cancelled, which is gives us meter plus meter. Now, it's also a same quantity which is on LHS. Now, by this, we can also say uh, B equation is also valid. Now, from this, you can easily say that in physics, which one is right equation or which one is not. Now, again, I take some example, right? Like V is equals to S plus, right, 18. Now, what is V? V here is meter per second. Now, velocity. What is S? S means distance, meter. Okay. Now, what is here? A means meter per second square, and T means time. Now, cancel it. Here we have meter, and we have here meters per second. Here is a catch. What is here? Which is meter and meter per second. This shows velocity and it shows distance. So we cannot add here velocity plus distance. Okay. And this is also wrong. By this, you can say this equation is totally wrong. This is all about the anatomy of balance equation. For true equation, it must be same units. As I show, now go on. Now, in physics, laboratory experiment is a crucial thing. Now, in the theory, we made a theory and we have to experiment in laboratory. After the doing experiment, we got some results, but results may be accurate or inaccurate, and the precision precise some way or somewhere not precise. So first we understand what is accurate result or precise result. Now, accuracy means how close your measured value or true value. Like let's example means true value. True value is like 23, okay, meter, and we got ex experiment value, which one is 24 meter. So the difference between these two, true value and experimental value, which is 1 meter. On the other hand, some other student perform the experiment and he got like 95 meter, and the difference is here is 2 meter. So we can say this value is more near to the true value, means it has a more than this. Okay, it's about accuracy. Now let's understand what is precise value. Now for precision, uh, consider some scenario. You perform an experiment and you got value like 5 kilogram. Now, after doing this experiment, you are not satisfied. Then you perform another time and you got a result like 25.5 kilogram. And third time you experiment and you got the result like 26 kilogram. These values are very close. You see here, zero point 0.5 kg difference here is like a more precise value you will get in your experiment. On the other hand, consider this one. You performed an experiment and you got the value like 600 meter per second. You are not satisfied, and you perform second time and you got the result like 700 meter per second. You are not satisfied yet, and you perform third time and you got the answer like 800 meter per second. Here you can see there is a 200 meter per second difference, which is not negligible from this. Okay, so it means the repetition of your experiment gives the same amount, likely same amount, not exact value, but it is, you can say, high precise value. You can say it's called precision, but here you got 100, and 200 meter per second difference. This is not high accurate value. Okay, this is about what is accuracy and what is precision of your result. Okay, now why we got like this? There is a possibility of human error, environmental issue, or you can say many times the apparatus or apparatus error calibration on the apparatus is not better. Okay, so in which condition you will get high accurate result and which condition you will get precise value. Now, in the first case, you have accurate and precise value, and you got like this. In the middle is your target. You got very nice result, and this is very accurate and precise value. Now go on the second scenario, which is a precise but not accurate. This is our target, okay? But here precise means you got you repeat the same experiment twice, thrice, okay? But you got result like near about this amount. Like I said, 25, 25.5, 26 kg, okay? But you don't get true value, okay? Not accurate. Accurate means true value is not near to the experiment value, but you get the same result while you're doing same and same experiment, which is called systematic error, calibration issue. We go on this later. First, we saw a third scenario, which is accurate but not precise. Now, for accurate, we have to understand the true value, which is here, and you got result like this. Red dots are you perform the result and you the result. Now, this is our target. Okay, you have a one precise value here, which is very near. Second one is this is far from this one, and third like you got like this. But here, one thing is not that this value, your you can say your uh, result are not precise. Here you see very near, close, and these are this one is here, one is here, one is here, one is here. So this is not precise, but this is accurate. Okay, and this is called a random error. Now go on neither, and this is not accurate or not precise, and your supervisor will be angry on you, and you got 0 marks in your exam. So so this is a not precise. This uh, result is not very near, and this is not actually near to this also. Okay, this is not precise and accurate. So now let's see what is systematic error and random error and how to omit it and to get a real result. Now go on. I talk about systematic error and random error previous slide. So first we see a systematic error. What is its effect? Shifts all the readings by a fixed amount. Now let's take some example. If you have a scale, okay, but your scale is broken. Now you have a calibration like this, 2 centimeter, 3 centimeter, four, like that, and this is a 1 centimeter. In actual scale, you have a zero, one, two, three, four. Okay. Now you may measure some length from this scale. You got the wrong result. Why? Because here start from one, not from zero. Here you see. So every result you will get is short. Okay, let's some example. This like this. Okay, this is some kind of a like wood, something wood, which is actually 2 centimeter. Okay, now what you got here, which the actual value, actually it is a 2 centimeter. Now you can measure from this scale and you got three. and you write 3 centimeter length. Now, for the actual scale, you got 2 centimeter. Okay, this is a systematic error. You measuring truly, but apparatus, or you can say scale has a defect or error, so you will get error. Now shifts all the reading by a fixed amount. Okay, for once you identify this error, you have to just do -1 and 2 centimeter. Whenever you measure from this scale, you have to add one more thing, -1. So you will get the right result. That's why I say here cause zero errors, wrongly calibrated scale. So here you see a wrongly calibrated, but so this is not human error or kind of nature error. Okay, this is the calibration issue of your scale. Okay, now how to fix it? As I mentioned, as I talked to you, improve experimental technique and subtract the error. We subtract -1 from all our readings from the measuring that defective piece or defective uh, scale. Okay, random error is scatter down the true value. What is the cause here? Human reaction time, parallel error, and fluctuating reading. Now, consider the scenario A and B. Person A performs some experiment and he got a result about 30 centimeter. Now, the same time, same uh, apparatus you will be given to B. He got some value like 40 centimeter, not 40. Let's say suppose 31 centimeter. They both have a same environment, same apparatus, same lab, but their results are different. Here you can see. It is a human error. Okay. Now consider some other scenario like we have a only person A. He do some experiment in morning. Okay. And he got result about 20 centimeter. Okay. Now after some time in afternoon, he made same experiment. He used same lab and but he got 21 centimeter answer. After some time in the evening, he performed same experiment, same lab, but he got some value like 20.5 centimeter. A is here, okay? The experiment is there, same person, same lab, but the values are different. Because why? The time is different, morning session, afternoon, and evening. It is about temperature related, humidity sometime cause the error. It's all in the random error. So we understand systematic error and random error. For the systematic error, we see we see that it is caused by some apparatus or a calibration issue, and on the other hand, random error is caused by a human error, you can say, or some time difference. Okay, this is all about systematic error and random error. Now go on. As we talk about the laboratory experiment, when you perform a calculations with many lab data, how do you track the total uncertainties? It depends entirely on what you are doing with data. If you add and subtract the values, you have to add these uncertainties individually. Okay. If you multiply, divide, let's suppose x is equal to y into z, then add percentage uncertainties delta x upon x, delta y upon y plus delta z upon z. Now, if you dealing with powers and if you have an equation of power and you will get some error, then you have to omit by this equation. Delta x upon x is equal to a into y, delta y upon y. So now let's some example. Now we have here x is equal to y plus z. Y is a first reading, okay, and z is a second reading. So how to omit the error and how to identify the error? So we have a delta y plus delta z. This is called delta y, which means the reading will be different by the zero point 0.1 plus or minus. It depends on the application and calibration issue. And the second one is zero point 0.3 maybe or plus or minus zero point 0.3. And how will you do? It's about zero point 0.1 plus zero point 0.3 means zero point 0.4 plus or minus in the error of delta x reading. Now, for I take a one formula here, v is equal to s upon t. Now, s has a absolute value 100 plus uncertainty about 2 plus or minus 2. You can say in t, we have a t is 20 is a absolute value and plus or minus they have a zero point 0.5 uncertainty. Now, we have to calculate the percentage of uncertainty in s, which is given by 2 upon the value here, put here 100 into percentage means multiply by 100 is 2%. While in t, you have to do zero point 0.5 upon the 20 into 100 means 2.5 percentage. Now, for v, we have to calculate percentage of uncertainty in v means delta s plus delta t. So 2 plus 2.5 means 4.5% percentage of uncertainty in v. Okay, this is about the combining uncertainties. If you equation like this plus or minus here also you can do like this and multiply and divide equation, and if your formula contains some power then you can do like this also. Now go on. In a physics we deal with so many physical quantities. In that some of them are scalars and some of vectors. So what is a vector quantities and what is a scalar quantities? What is the properties of it? We will see in this video, this slide. Okay. Now, in scalar, we have a magnitude plus unit only. What does it mean? Uh, Let me give some example of scalars with speed. Uh, if you say someone, what is your car's speed, maximum speed? It says he says 200 kilometer per hour. We are talking about speed, okay? Uh, he says my car's highest speed is 200 kilometer per hour. Here, he mentioned magnitude. Yes, okay. He mentioned magnitude. Unit. Yes. I mentioned in, I think, second slide, you must write unit. value doing in physics. Okay, otherwise it will not make sense. Okay, we have a 200 kilometer per hour, so it uses magnitude and unit. He not mention about direction in the north, south, west, east. It doesn't care about because speed is a scalar quantity. Let's some other example, mass. Uh, if some body has a 30 30 kg mass, okay. So we are not saying the 30 kg mass in north direction, in south, at the angle of this direction. No, for the time we someone asked me to what time is it right now? I says 10 a.m. Okay, I'm not giving its direction. 10 a.m. in north direction, but in the south there is a 11 a.m. also. No, I'm not giving like that energy. If some box contain 10 joule, but 10 joule in what direction? It doesn't care because energy is scalar quantity. Now, if we talk about vectors, let me give some example. If you talk about velocity, many people don't know the difference in speed and velocity, but as you are a physics student, you must know the difference between velocity and speed. Okay, someone says, "What is the speed velocity of your vehicle?" It's a he says 10 km/h right now. In what direction? You have to mention while talking about velocity in north, south, whatever it is. But you have to mention in which direction are you going with how much quantity in vectors. Okay. Now, weight. Weight. I think you know about weight formula, which is the m into g. Here, m is the mass. Okay. And g is the gravity, you can say. So let's suppose some has a 30 kg mass. And for simplicity, uh, we take a 10 meter per second square, but actually it is a 9.8 meter per second square. But here we take some simplicity, 300 Newton. So weight, which is 300 Newton. But in some scenarios, people says that my weight is 30 kg, but it's wrong in physics. Your mass is a scalar, weight is a vector quantity. So you have to mention the weight, not only this, in you have to mention the direction also. Okay. Now talk about force. Now uh, let's talk about 10 Newton, suppose 10 Newton force. In what direction? You have to mention. If you do not mention, then it's improper in physics language, or it is wrong. If your answer is means 10 Newton, you like this, but examiner give you 0 marks. But you have to mention in which direction, north, south, x direction. You have to mention. Or one other thing in vector, you have to mention the vectors in like this, not only this. Scalars, you may write like speed means v only. When you deal with velocity, you have to write like this. Arrow must. You have to do arrow. value write vectors. Otherwise, it will shows only it is a scalar, means you are wrong. So whenever you write vector quantities, you must write like this. Okay, this is all about scalars and vectors. This is the mainly fundamental difference. Now go on. As I talk about vectors and scalars, if you add scalar plus scalar quantity, means scalar quantity. Okay, you don't need any extra mathematical work for that. You have to just add like you do in maths. Like let me just see some examples mm, like distance is about 3 meter. Some other distance 4 meter. Total distance is 7 meter. The distance is scalar quantity. Okay, so you do not mention direction. On the other hand, when you talk about displacement, which is a vector quantity, so in vector quantity you have to mention the direction also. So let's talk about displacement one in 4 meter in x direction. Okay, let me consider or establish some coordinate system here. This is the x direction, this is the y direction. Okay, we only did with in 2 2D. Now problem gives second displacement, which is a 3 meter in y direction. Okay, now if you add like you do in a distance, like this total displacement, which is 4 plus 3 is equal to 7 meter, is totally wrong. Totally wrong. Instead of this, we have to help with tip to tail method. What is tip to tail method? So let's suppose we have vector like this, some vector like force vector, okay? And now we do the same problem here, okay? The displacement vector 4 meter, okay? And this is the displacement. So we have to do some arrow, okay? Now in the x direction, as I establish here the coordinate system, okay? The 4 meter in x direction, we walk 4 meter in x direction. Now we have a displacement to 3 meter in y direction. Now in y direction, we have 3 meter, 3 meter. Okay. Now if this is the distance, then you have to add just 4 plus 3 is equal to 7 meter. But here we have displacement. So we have to add the tail of this first vector to head of the resultant position. This is the initial position and this is the final position. We have to draw like this, and this is the resultant displacement. Okay, so what is it? This is a 90-degree angle because this is the x direction and y direction has perpendicular to each other. So I hope you know the Pythagoras Newton's law. What do you say? Let's put a name here, A, B, and C. So AC square is equal to AB square plus BC square. Now we have a put the values here. What is AC? AC means R square. What is AB? AB means 4 square plus BC. BC means 3 square. And we got the 16 plus 9 means R square. And we got R is equal to 5. We let's do some extra step plus 9, which is root 15, and which is given by plus or minus 5. But here we talk about displacement. Okay, it is not always a positive type distances. Now we got 5 meter. Now one thing is the resultant is the shortcut from start to finish. When the main difference between distance and displacement is shortcut tree, shortcut method or shortcut route, you can say. Okay, and it's long distance, long journey, you can say. And this is all about tip to tail method. Now, there's some other example. If we have a vector like this and some other vector is like this, so you have to just put here and same direction. Now, this is the starting point, and this is the ending point. You have to just touch it, and this is the result. This is the first vector, second vector, and this is the resultant vector. This is the method of tip to tail method. In problems, we solve this this problem by using this method, so you can easily understand what is it, this tip to tail method. Now go on. Now the next topic is resolving vectors, the real metaphor. So why we need to resolve vectors? As I told you in the previous slide, which is I defined the coordinate system like x and this is the y. But in the generally, the vectors are not in the coincide with the x-axis or y-axis. Some are they like this vector, this a vector, okay, and this is our coordinate system x and y. So what we have to do? We have to resolve into components. One is on the x, one is on y direction. So let's understand this. So let's suppose we have a coordinate system here, x axis and a y axis, okay? And we have a, let's suppose this is a vector, okay? It made some angle with x axis, it's theta, okay? Okay, it's given, okay? Now we have to resolve a on x and y axis. I guess you may heard about trigonometry in maths. You deal with sine, cos, tan, cosec, and like that. Let's fresh, fresh up the concept. Like sine is given by opposite direction upon hypotenuse. Cos is given by adjacent upon hypotenuse. And tan, which is given by opposite side or upon adjacent side. Or another formula is for tan is sine upon cos. Okay, I hope you know this well because we use in this. So let's draw some dot line on x and y axis. Now let's suppose this value like a. Okay, a is magnitude. Magnitude is denoted by like this, or simply a you can write like this. Okay. Now take sine theta. Consider this. Uh, let's suppose P Q R. Consider this PQR triangle. And what is the value of sine theta? Sine theta means PR upon hypotenuse PQ. And given by PR means what? PR. We don't know PR, okay? What is PQ? PQ means A, and it is a sine theta. Okay. Now we got PR A sine theta. And we got A sine theta here. A sine theta. Now take cos theta. What is cos theta? Means adjacent QR upon hypotenuse PQ. Now, what is QR? We don't know. Means right as it is. PQ means A. So, what is the value of QR? QR means A cos theta. Now, for this triangle, we have a horizontal and vertical component. So, hori component, which is QR. QR is horizontal component, and this is a vertical component, you can say, which is A cos theta. And vertical component, which is PR, A sine theta. I hope you guys understand this theorem, or you can say proofment of value of QR and PR we are using in the every problems you will face. Okay, by the practice, you will understand that. This is a resolution of in two component of this A vector. If you add these two vectors, let me do is um, let's suppose PR plus QR is PQ. I take from the here is 90-degree angle. Okay, so it is a Pythagoras theorem. Okay, so what is a PQ square? Means A square. What is PR square? A square square theta plus what is a QR square? A square cos square theta. Now take A square common outside the box and we left with sin square theta plus cos square theta. You know what is a cos square theta plus sin square theta means 1 means A square. We got the same LHS here. So the same vector, you can say same magnitude, it is divided by, you can say, given by A sin theta or A cos theta. Why we use that? You can relate when we solve a problem. Okay. To wrap up our first lecture, let's look at your completed physics foundation toolkit. Okay. First, units. Always write units. Okay. Use and check homogeneity of the equation as we do in work is equals to kinetic energy plus potential energy. Okay. Now, in errors, we have two types of errors, systematic and random. We talk about systematic and random, how to remove it. We also see the how to remove it, the many techniques, and how to combine the uncertainties correctly. We also see three types, means x is equal to y plus z, and if they given a multiplication and if they gave like power, we we see three all kind of problem, and how to get the total uncertainty we also see. And now the last one is vector. In vector you have to mention a direction always. Okay, without direction vector is nothing, it means useless. Okay, and for adding vectors we have to use a method, tip to tail method, like this one vector, this second vector, and this is the resultant vector. And the last one we saw uh, resolve vector. If a vector is not given in a specific direction, like x in x-axis, y-axis, if not, we have to resolve in x. What is the resolution? And y, we have to deal with that. Okay. Keep these three pillars in your mind, and you are ready to tackle any problem physics throws at you. In our next video, we will transition from theory to practice. We will dive straight into step by step problem solving, unit conversions, uncertainty calculations, and vector geometry problems together. Make sure you have your calculator, a notepad, your geometry toolkit ready. Thank you for watching my video. Subscribe for more physics lectures.